Alright class, so last time we went over redox reaction. When we say redox reaction are the transfer of electrons, the movement of electrons, and because electrons moving, the charges change. Whereas a double replacement reaction, the charges don't really change, you just switch partners. But redox, the charges change. That's really key because the electrons are moving, so the oxidation state changes. So this is a redox reaction over here. Now let's do a practice problem before we move on. If you remember, we talked about oxidation and reduction. What I want you to do, I want you to figure out what's been oxidized, what's been reduced, what's an oxidizing agent, and what's the reducing agent. If you don't remember it, go back to my redox video. Make sure you are comfortable with that before you're doing this one. Okay, so pause this and figure that part out. So hopefully what you said. Let's look at the easy one first. The easy one to look at is iodine. Right here, iodine has a charge of -1. If I give you a charge, that's the charge of the compound. Now, how about over here? What's the charge of I2 over here? Remember, I2 over here is a diatomic molecule, and we said diatomic molecule because that's how they exist in nature. Their charge is 0. Their charge is 0. So anything by itself has a charge of 0, like, sodium metal, copper metal, aluminum metal. Anything by itself has a charge of 0. Also, diatomic molecules have a charge of 0 because that's how they exist in nature. Now here, I give you a charge. If I give you a charge, it's an ion and it's going to have a charge. So I go from -1 to 0. What happened? I became more positive. If I become more positive, what am I? I am oxidation. Beautiful. Now, let's come over here. Here, I have chromium, has a charge of +3. We want to know what was the charge of chromium on the reactant side, and did it change or not change? Okay, so the way I can do this, CrO4 -2, I showed you guys a cool way to do this, which is the entire thing equals -2 because that's the charge of the compound that I've given you. And if you remember, we said oxygen is always -2, never changes, times 4 would be -8. And then I can easily solve for chromium, which would be +6. So here, chromium went from +6 to +3. It got more negative. So what is this? This is reduction. And remember, for redox reaction, one has to oxidize and the other one has to reduce. So if you do the problem and you get oxidation for both, you messed up somewhere, right? One has to be oxidized, one has to be reduced. Beautiful. Now, last thing I ask you to do, oxidizing agent, reducing agent. Remember the opposite. So this one got reduction, which means this is my oxidizing agent. This one is oxidation, so this is my reducing agent. And the agent or the reactant on the reactant side, or the reagent on the reactant side. So far, so good? Okay. Again, remember, for polyatomic ions and covalent compound, we have to do this rule for polyatomic ion and covalent compound. Beautiful. So you figured out what's been oxidized, what's been reduced, oxidizing agent, reducing agent. The next thing to do and to learn is balancing redox reaction. You know how like when we had a double replacement reaction, inis with inis, outis with outis, and you would use the solubility rule to see what happens to the reaction? For redox, we need to learn to balance redox reaction. I emailed you guys a handout. Take out that handout so you don't have to write as much. Here's a handout, okay? So we're going to balance redox reaction. So what I want you to do, rewrite the question that I just gave you, which was CrO4 -2 plus I minus goes to I2 plus Cr plus 3, okay? So write that one down first. Beautiful. Okay. Now, rule number 1. What is rule number 1? Write 2 half reaction, each one involving one element changing oxidation state. Okay, so the first thing we're going to do, we're going to write down 2 half reaction. So what are the 2 half reaction over here? Over here, I'm going to write the easier one. It would be CrO4 -2 goes to Cr plus 3 and I minus went to I2. These are my two half reactions. Then what you're going to do, you're going to balance everything except oxygen, hydrogen, and charges. Okay, I'm going to balance everything except oxygen, hydrogen, and charges. I have 1 Cr over here, 1 Cr, I'm okay with that. I have 1 iodine here, I have 2 over here. So what I have to do, I have to put over here. So now I have 2I, I'm good. Then what am I going to do next? I'm going to balance the oxygen by adding H2O to the side that doesn't have enough oxygen. Okay, so I'm going to add oxygen to the side that needs oxygen. Let's do this together. How many oxygen do you have on this side? Nothing. How many oxygen do I have on this side? You have 4 oxygen on this side. So what do you think is going to happen? I have to add 4 H2O on the side that is oxygen deficient. So you balance the oxygen by adding H2O. Let's come down over here. No oxygen, I'm okay. Now, the next thing you're going to do, you have to balance the hydrogen by adding H plus to the side that doesn't have hydrogen. Pay attention to this. How many hydrogen do I have on this side? Nothing. How many hydrogen do I have here? 4 times 2 is 8. I have 8 hydrogen here, nothing here. So what I'm going to do, I'm going to add 8H plus to this side. Okay, let's come down over here. Any hydrogen here? No. Any hydrogen here? No. Okay, so let's summarize it again. You put 2 half reaction. Then you balance everything except oxygen, hydrogen, and charges. Then you balance the oxygen by adding water. Then you balance the hydrogen by adding H plus. Beautiful so far. Now the last thing we have to do, we have to balance the charges by adding electron to the more positive side because electrons are negative. Let's go over this. Probably this part is the hardest part of balancing, so pay attention for me. Let's come over here. On this side, what is the overall charge on this side? I have 1 chromium plus 3 and water is neutral. So my entire charge over here would be plus 3 because I have 1 chromium plus 3 and water is neutral. Now how about on this side? On this side, do it with me, I have 8 pluses and 1 minus 2. I have 8 pluses and 1 minus 2. So together it would be plus 6. Okay. Now, the charges don't match. What I have to do, I have to make sure these two, I have to match them up. So, you balance the charges by adding electron. But electrons are negative. Because electrons are negative, we have to add it to the more positive side, which is this side. How many do I need to add? Hopefully you're telling me right now that you need to add 3 electrons. Again, because electrons are negative. So if I add 3 electrons to this side, 6 minus 3, it would be 3, and it would match up with a charge on this side, which is 3. So far, so good. All right. Now let's come down here. What's the charge over here? Over here, I have 2 minus 1, right? So the charge is minus 2, and the charge over here is 0. If I don't give you a charge, don't get fancy on me and add a charge. All right. Now, which one is a more positive side? Minus 2 is 0. 0. How many electrons do I need to add? If I add 2 electrons, because electrons are minus, then what I would have minus 2 on this side, and it would match up the minus 2 to the other side. All right, beautiful. We're almost there. All right, now the last thing we're going to do. Now, check this out. If I have $10 and if I lose my $10, how much do you get? You get $10. If I have $20, I lose my money and I give it to you. How much do you have? You have $20. Okay? I lose 10, you get 10. I lose 20, you get 20. Well, check out here. This one got 3 electrons. This one lost 2 electrons. This cannot be happening. These two have to be exactly the same because I lose 10, you get 10. I lose 20, you get 20. That's not the case here. These two numbers has to be the same. Now they're not. What can we do? We can make him to be the same. How do we do that? What if I multiply this by 2 and I multiply this by 3? Then I would end up having 6 electrons here and 6 electrons on this side. Because then I would have gain 6 and lose 6. The problem is I can't just multiply the electron. I have to multiply the whole equation. Over here, I can't just multiply the 2 electrons. I would have to multiply the whole equation. Okay, hopefully you guys follow that so far. All right, now the last thing to do, right here, we're going to add the 2 half reaction back together and cancel out anything that we can cancel out. Because if you remember at the beginning, we made 2 half reaction. We're going to combine them back together. We're going to add up all the reactant together, and we're going to add up all the product together. We're going to add up all the reactant together. We're going to add up all the product together. The one thing you have to pay attention to, don't forget to multiply these out. So let's do it together. I would get, I would get 6 electrons plus 2 times 8 hydrogen, it would be 16H plus 2 CrO4 minus 2 plus 6I minus. Because after I added this, I have to come back here. I'm combining them together. Okay. Now, I'm going to go to the other side. I would have 2 Cr plus 3. How many water? I would have 8. I would have 8. That's a bad looking 8. I would have 8 H2O. Then what I'm going to do, then when I come down here, because I'm adding all this together, I would have 3I2 and 6 electron. I would have 3I2 and 6 electron. So far so good. Now hang in there for the last part. Then you are going to cancel whatever you could cancel. At this point, one thing that you must be able to cancel are electron. And yes, I can cancel the electrons. If you get to this point and you cannot cancel out electrons, that's a bad sign, right? You have to go back again. So when you get to this point, you should definitely be able to cancel electron, and anything else in this case is only electrons. Okay, beautiful. So we just balanced a redox reaction. Now I want to give you a shortcut. You don't have to learn this, but I really like this. We call it the RR rule. You ready? Here's what the RR rule says. If you add electrons to the right side, that is reducing agent. If you add electron to the right side, that's your reducing agent. Which means the other one is going to be the oxidizing agent. Okay, so let's do this one together. Again, if you add electron to the right side, that's your reducing agent. We call it the RR rule. So let's come over here. Pay close attention. I added electrons to the left side here. I added electrons to the right side. Left side, right side. If I add electrons to the right side, that means this is my reducing agent. Remember, the agent have to be one of these two because the agent have to be on the reactant side. So if I add electrons to the right, which I did over here, that means this guy is my reducing agent, right? That means the I minus is my reducing agent. If the I minus is my reducing agent, that means the chromate has to be my oxidizing agent because the other one has to be the oxidizing agent. Now, let's see if this is correct. Remember, we did this already. Yeah, I minus reducing agent, chromate oxidizing agent. Isn't that cute? So that's a way to double check your answer. Again, you add it to the right, that's your reducing agent. All right, beautiful. Ready to do one more practice problem? Let's do this. Here is a redox reaction. Now, before we do the redox reaction, before we balance it, pause my video, figure out what's been oxidized and what's been reduced. Okay, let's do that without balancing it first. So here, what is a charge on 10? Again, when I give you a charge, that means that's the charge, right? That's the oxidation number. What's the charge on 10 over here? +4. So 10 went from +2 to +4. It became more positive or more negative? It became more positive. When you become more positive, what are you? You are oxidation. Remember that. Oxidation is loss of electron, and you became more positive. So far, so good. Now, which we know, that means the other one has to be reduction, but let's double check it. Over here, this is the easier one. What is the oxidation number of I over here? Hopefully you shouting is 0, because all the diatomic molecules, that's how they exist in nature. So their charge, their oxidation number is going to be 0. Now, over here, when you form a compound, then you have an oxidation number. Then you have a charge, right? How are we going to figure it out? That's the covalent compound. That's the covalent compound. That's the polyatomic ion. So we need to figure out the oxidation number of iodide. Again, I'm going to repeat this one more time. When you have diatomic molecule or anything, any metals by itself that is neutral, is going to have a charge of oxidation number of 0. But when you form a compound, then you are going to have a charge. You're going to have an oxidation number. Ionic compound is the same as their charges, as the ionic charges. Oxidation number is the same as ionic charges. For covalent compound, we have to figure it out. And again, go back to the last video to review that. The way we do it, the entire thing has a charge of what? -1. Is not neutral. The entire thing has a charge of -1. I give you the charge. Okay. Now we know oxygen is always -2. -2 times 3 is -6. So my I is going to be +5. My iodine is going to be +5. So iodine went from +5 to 0. It became more negative. When you became more negative, you are reduction. Again, one is oxidation, one is reduction. That's what you kind of expected. Okay, now what we're going to do, what is oxidizing agent? What's the reducing agent? Remember, we talked about it. They are the opposite, and the agent are always on the reactant side. I need to remember that. So, this guy got oxidized, which means this is a reducing agent. And then this one got reduced. This has to be oxidizing agent. We're good so far? Okay. So this is, hopefully you got this down. And I want to do this really quickly again to remind you that redox has 2 parts, oxidation and reduction. And don't forget, oxidation is loss of electron. You become more positive and you are a reducing agent. Reduction, gain of electron, you become more negative and you are an oxidizing agent. You are the opposite, and we talked about it last time why that is. So far so good? Okay, beautiful. Now rewrite the same equation, because what we are going to do now, we are going to balance this. Okay, pause my video and balance this redox reaction using the rules that I had emailed you and we just went over. So here are the rules again. All right, so rule number 1, we're going to write 2-half reaction, right? So the 2-half reaction, Sn plus 2 goes to Sn plus 4. And then iodate goes to I2. You write down 2-half reaction. Rule number 2, you balance everything except oxygen, hydrogen, and charges. So I have 1 SN, 1 SN. Okay, don't worry about the oxygen. Here I have 1 I. Here I have 2 I. Okay, so what do I have to do? I have to add a 2 over here. So then I have 2 I. I have 2 I. Then you balance the oxygen by adding water. I have no oxygen here. I have no oxygen here. How many oxygen do I have here? Be careful. Because I have 2 iodate now. So I have 6 oxygen here. And I have no oxygen here. 6 oxygen here, no oxygen here. So you balance the oxygen by adding water to the side that does not have oxygen. Then you balance the hydrogen by adding H+. No hydrogen, we're okay. How about over here? No hydrogen, how many hydrogen? I have 12 hydrogen on this side. So no hydrogen, I have 12 hydrogen on this side. So I'm going to add 12 H pluses to the side that has no hydrogen to balance it out. So we balance the oxygen by adding water, hydrogen by adding H+. Now the last thing is balancing the charges. What's the charge on this side? +2, right? What's the charge on this side? I give you a charge, that's the charge of the compound. It's +4, okay? So I went from +2 to +4. You have to balance the charges by adding electron to the more positive side. Which one is more positive side? This one right here. How many electrons do I need to add to balance it out? Remember, electrons are the negative. So 2 electrons. If I add 2 electrons, then +4 minus 2, this would be +2 on this side, and it will match the +2 on the other side. Beautiful. Now, let's come down here. What's the charge on this side? I have 12 pluses, and I have 2 minuses. I have 12 plus, and I have 2 minus. 12 plus and 2 minus, so together I have 10 electrons. Sorry, 10 plus 10 charges. Okay, I'm going to do this one more time. I have 12 pluses and 2 minuses. 12 minus 2, I have 10, the charge of 10 on this side. How about over here? I have, this is 0, this is 0. These two are neutral compound. If I give no charge to you, don't just make up charges for them, right? They're neutral, they have no charge. Okay, so you balance the charges by adding electron to the more positive side, which is this side, right? Now, how many electrons do I have to add? This is 0 and this is 10. So I would have to add 10 electron, because if I add 10 electrons, electrons are negative. 10 minus 10, this would be 0. It would match that. Beautiful. Here's the problem. If I lose $10, you gain $10. I lose $20, you gain $20. This cannot be happening. Here, this guy lost 2 electrons. This guy got 10 electrons. Lost 2, got 10. No, we can't do that. We can't just create electrons. They don't grow on trees. So what we have to do, we have to make sure these two numbers are exactly the same. Okay, how do we do that? I can multiply this by 5. If I multiply this by 5, then this is 10 and this is 10. They would match up. But I can't just multiply the electron. I would have to multiply everything. So again, we are this rule right here. Multiply a reaction by a factor that allows the electrons to be cancelled out. We did that. This would be 10. Then it matches that one. So there's nothing I need to do to the bottom one. All right. That was great. Now the last part is we have to combine all of these back together, all the reactant, and combine all the products together. But when you do that, don't forget to multiply this out. So what do we get? We get 5 Sn plus 2. I'm going to come down here, 10 electrons. I'm going to adding all the reactant together, 12H plus, and then 2 iodate. I'm going to go to the product side. I have to multiply this out. So I would have 5 Sn plus 4, 10 electrons. I'm going to come down there. I have I2 and 6 H2O. Is there anything I can cancel out? Yes. Electrons match it up and I can cancel out. There's really nothing else. So life is good. Now we want to double check ourselves. We figure out what's been oxidized, what's been reduced, oxidizing agent, reducing agent. I showed you a shortcut. the RR rule. Let's confirm that what we had talked about actually is lining up with this. I said if you add electrons to the right, that's your reducing agent. Okay, so which one the electrons are added to the right? This one, the electrons are added to the left. This one is added to the right hand side. Okay, so electrons are added to the right hand side. If you add electrons to the right, that means this guy is going to be a reducing agent. Because remember, the agent always have to be on the reactant side, right? Add electrons to the right, that's a reducing agent. Ooh, does that match up with what we had before? I hope so. Hey, it does match up, right? It does match up. So that's a good way to confirm. And again, if that's reducing agent, the other one has to be an oxidizing agent. All right, beautiful. Okay, very nice job. And next time, we're not going to do anything. We're just going to keep doing more practice problem with balancing redox. So make sure you got this down before we move on to the next part. I will see you guys next time to do more practice.